Hello, science enthusiasts. Welcome to an exciting journey into the world of chemical reactions. Today, we're diving deep into the fascinating realm of oxidation and reduction, also known as redox reactions. These reactions are fundamental to life and technology. They power our bodies, fuel our cars, and even prevent our bridges from collapsing. So, buckle up as we unravel the mysteries of the redox battle. Let's start with the basics. Oxidation, at its core, is the loss of electrons by a molecule, atom, or ion. Think of it as a substance becoming more positive. Conversely, reduction is the gain of electrons. When a substance is reduced, it becomes more negative. Remember, oxidation and reduction always occur together. You can't have one without the other. To help you remember, just think oil rig. Oxidation is loss, reduction is gain. This simple mnemonic will be your best friend in the world of redox. Redox reactions are the unsung heroes of energy production. Consider combustion, the burning of fuel. This is a classic example of a redox reaction. In combustion, fuel like wood or propane reacts with oxygen. The fuel is oxidized, losing electrons, while oxygen is reduced, gaining electrons. This electron transfer releases energy in the form of heat and light. Our bodies also rely on redox reactions for energy. Cellular respiration, the process by which we convert food into energy, is a series of carefully controlled redox reactions. Glucose is oxidized, and oxygen is reduced, providing us with the energy we need to live. Batteries are another prime example of redox reactions in action. A battery uses a chemical reaction to generate electricity. This reaction involves the transfer of electrons from one material to another. In a typical battery, one electrode undergoes oxidation, releasing electrons. These electrons flow through an external circuit to the other electrode, where reduction occurs. This flow of electrons is what we know as electricity. Different types of batteries use different materials and redox reactions. But the underlying principle remains the same. Electron transfer drives the electrical current. Our bodies are veritable redox reaction powerhouses. Metabolism, the sum of all chemical processes in our bodies, relies heavily on redox reactions. Enzymes play a crucial role in facilitating these reactions. They act as catalysts, speeding up the transfer of electrons between molecules. This allows our bodies to efficiently extract energy from food and carry out essential functions. For example, the electron transport chain in mitochondria is a series of redox reactions that generate ATP, the energy currency of our cells. Without these reactions, life as we know it would be impossible. Redox reactions are not confined to laboratories and textbooks. They are all around us, shaping the world we live in. Rusting, the formation of iron oxide on metal surfaces, is a common example of oxidation. Iron atoms lose electrons to oxygen, forming rust. This process weakens the metal and can lead to structural failure. On the other hand, antioxidants found in many fruits and vegetables prevent oxidation. They donate electrons to free radicals, preventing them from damaging cells. This is why antioxidants are so important for our health. Another example is the bleaching of clothes. Bleach contains oxidizing agents that break down colored compounds, making them colorless. This is why bleach is so effective at removing stains. Balancing redox reactions can seem daunting, but it's an essential skill for any chemist or engineer. The goal is to ensure that the number of atoms and charges are equal on both sides of the equation. One common method is the half reaction method. This involves breaking the overall reaction into two half reactions, one for oxidation and one for reduction. Each half reaction is balanced separately, and then the two are combined to give the balanced overall reaction. Another method is the oxidation number method. This involves assigning oxidation numbers to each atom in the reaction, and then using these numbers to balance the equation. Both methods require practice, but they are powerful tools for understanding and manipulating redox reactions. Redox reactions are indispensable in various industries. In metallurgy, they are used to extract metals from their ores. For example, iron ore is reduced to produce pure iron. In the chemical industry, redox reactions are used to synthesize a wide range of products. From pharmaceuticals to plastics, they are also used in wastewater treatment to remove pollutants. The food industry also relies on redox reactions for preservation and processing. For example, antioxidants are added to food to prevent spoilage. The study of redox reactions is an ongoing field of research. Scientists are constantly discovering new redox reactions and finding new ways to apply them. One exciting area of research is the development of new battery technologies. Researchers are exploring new materials and redox reactions to create batteries that are more efficient, longer lasting, and environmentally friendly. Another area of research is the use of redox reactions in medicine. Scientists are developing new drugs that target specific redox reactions in the body to treat diseases like cancer and Alzheimer's. Oxidation and reduction reactions are fundamental to life and technology. They power our bodies, fuel our industries, and shape the world around us. Understanding these reactions is essential for anyone interested in science, engineering, or medicine. So, keep exploring, keep learning, and keep unraveling the mysteries of the redox battle. Thank you for joining me on this exciting journey.